There are many different ways of knowing or getting new information. In our everyday lives, we tend to rely on memory and language and intuition. Sometimes we call this traditional ways of knowing. In science, we tend to lean more on reason and language and using our senses for observations. In this lesson, we're going to talk about a scientific framework called claim, evidence, and reasoning. CER can be used in lots of different subjects, such as history and literature. But the way we use it in science is a little bit different. When we make a claim, we are trying to prove something or give an explanation. Anyone can claim anything, but it is not accepted until it is backed up with evidence. What is evidence? It's the gathering of facts. What are facts? They are observations that people can agree upon. Can you see how I'm getting very specific about definitions? I'm doing that because the reasoning part depends on explaining exactly how the evidence ties back to the claim that you're making. Things are always better with some examples. Here are some regular dice, and here are some skew dice. I say to you, let's use these skew dice in our game. And you look at me and say, I don't think so. Those don't look fair to me. I claim these skew dice are fair. You claim they are not. Now I have to provide you with some evidence. We will take one skew dice and one regular dice, and we roll them 60 times each. We create a little chart of what the results look like. The final part now is to summarize, but not just any summary. We need to tie the evidence back to the claim. This is called reasoning. My claim is that the dice are fair. The definition of fair is that every number has an equal chance of being rolled. My evidence shows that after testing the skew dice and the regular dice, there's an equal chance or equal probability of every number being rolled. They don't actually come out to be equal because it's random. My claim stands that skew dice are fair because the evidence provides facts that we agree upon, and they apply exactly to the definition of what fair means for dice. Let's do another one. I claim that a paperclip can float on water. Remember, we have to be specific about the words in this claim. What is water? It's the liquid that comes out of my sink. What is float? I say it means to rest on top of the water. So I show you this. I set this paperclip on top of the water, and I even set a plastic paperclip on top of the water. So, my claim is true. It rests on top of the water. You say, now hold on. Not so fast. Bloop, bloop. The actual definition of float is that an object comes back up when pushed underwater, like a piece of styrofoam. Our conclusion must make a logical connection to an acceptable definition. The claim evidence reasoning framework is a powerful tool for making new learning happen and proving new things in science. In summary, we have to remember that the claim is a specific definition. It's what you want to prove. It's an answer. Here are some claims that we made today, and here are some specific definitions. The reasoning has to show how the observations and data support or don't support a specific definition in the claim. If the reasoning is not there, then the whole thing falls apart.